To determine if a design is suitable for a Class 1, Group D, Division 2 area, one must consider several factors pertaining to the equipment and installation. Specifically, when mounting an unclassified Genset controller, such as a Thomson Technology ME-C20, in a Type Z purged enclosure with a gasketed door locally mounted on the Genset alongside a locally mounted gas detector with alarm horn and beacon with a sign reading "Do Not Open Panel IFGAS" is present, adherence to specific safety standards is crucial. The answer provided suggests that the design is indeed suitable, contingent upon meeting certain requirements. Let us delve into a detailed discussion of these requirements and the underlying principles that govern safe operation in hazardous locations. Firstly, it is stated that the Genset controller and gas detector must be intrinsically safe, often abbreviated as IS. Intrinsic safety is a protection technique applied to electrical equipment and wiring for hazardous locations where the hazard is due to the presence of flammable gases or vapors, combustible dusts, or ignitable fibers or flames. In an intrinsically safe circuit, the energy, both electrical and thermal, is limited to a level below that required to ignite a specific hazardous atmospheric mixture. This is achieved through the design of the electrical circuits and components to limit voltage, current, and stored energy. It's essential to ensure that both the Genset controller and the gas detector are certified as intrinsically safe for Class 1, Group D environments. This certification ensures that these devices will not cause ignition even under fault conditions. The design and certification of intrinsically safe equipment must comply with recognized standards such as those issued by the International Electrotechnical Commission (IC) or other relevant national standards. These standards define the testing and assessment procedures required to demonstrate compliance with the intrinsic safety concept. Secondly, the purged enclosure must be certified for Class 1, Group D, Division 2 hazardous areas. Purging is a technique used to reduce the concentration of flammable substances within an enclosure to a safe level. A Type Z purge specifically reduces the classification within the enclosure from Division 2 to non-hazardous. The enclosure is pressurized with a clean, inert gas, typically compressed air or nitrogen, to prevent the ingress of flammable gases or vapors. The certification of the purged enclosure for Class 1, Group D, Division 2 indicates that the enclosure has been tested and approved to maintain a safe internal environment when properly purged and pressurized. The certification process involves rigorous testing to verify the enclosure's ability to withstand the pressures and environmental conditions associated with hazardous locations. It also ensures that the purging system is capable of effectively removing flammable substances and maintaining a safe internal atmosphere. Thirdly, the enclosure door must be gasketed to prevent the ingress of flammable gases. Gasketing is a critical aspect of enclosure design for hazardous locations. The gasket forms a seal between the enclosure door and the enclosure body, preventing the entry of flammable gases or vapors into the enclosure. The gasket material must be compatible with the chemical environment in which the enclosure is installed and must maintain its sealing properties over a wide range of temperatures. Regular inspection and maintenance of the gasket are essential to ensure its continued effectiveness. Damage or deterioration of the gasket can compromise the integrity of the enclosure and increase the risk of ignition. The type and quality of the gasket material are crucial factors in the overall safety of the enclosure. Fourthly, a sign must be posted on the enclosure that reads "Do Not Open Panel IFGAS" is present. This sign serves as a visual warning to personnel, alerting them to the potential hazard of opening the enclosure when flammable gases are present. The sign should be prominently displayed on the enclosure and should be easily visible and legible. The lettering should be of sufficient size and contrast to ensure that the warning is clearly understood. The sign should be made of a durable material that can withstand the environmental conditions in which it is installed. Regular inspection of the sign is necessary to ensure that it remains in good condition and is not obscured by dirt or debris. The presence of this warning sign is a critical element in the overall safety strategy for the installation. Fifthly, the alarm horn and beacon must be visible and audible from outside the hazardous area. The alarm horn and beacon provide an audible and visual indication of a gas detection event, alerting personnel to the presence of a hazardous condition. The alarm horn must produce a sound level that is sufficient to be heard above the ambient noise level in the area. The beacon must be visible from all directions and must be of sufficient intensity to be seen in bright sunlight. The placement of the alarm horn and beacon should be carefully considered to ensure that they effectively communicate the alarm condition to all personnel in the area. Regular testing of the alarm horn and beacon is essential to ensure that they are functioning properly and are capable of providing timely warnings of hazardous conditions. In summary, the suitability of the design for a Class 1, Group D, Division 2 area depends on the following considerations. The genset controller and gas detector must be certified as intrinsically safe, meeting applicable safety standards. The purged enclosure must be certified for use in Class 1, Group D, Division 2 hazardous areas. The enclosure door must be effectively gasketed to prevent the ingress of flammable gases. A prominent warning sign must be posted on the enclosure, cautioning personnel against opening the panel if gas is present. The alarm horn and beacon must be clearly visible and audible from outside the hazardous area. These requirements collectively ensure that the genset controller and gas detector are adequately protected from flammable gases and that any potential hazards are effectively communicated to personnel, maintaining a safe operating environment. Let's now further elaborate on the technical aspects of each requirement, providing a more in-depth understanding of the principles and practices involved. Intrinsic safety is detailed. Intrinsic safety is a protection technique that relies on limiting the available electrical and thermal energy in a circuit to a level that is below the minimum ignition energy (MI) of the hazardous substance present. The design of intrinsically safe equipment involves careful selection of components and circuit configurations to ensure that voltage, current, inductance, and capacitance are all maintained within safe limits. Intrinsically safe circuits are often characterized by the use of current-limiting resistors, voltage-limiting diodes, and other energy-limiting components. The certification of intrinsically safe equipment involves rigorous testing to demonstrate compliance with applicable safety standards. These tests include subjecting the equipment to various fault conditions such as short circuits, open circuits, and component failures to verify that the energy levels remain below the ignition threshold. Intrinsically safe equipment is typically marked with specific symbols and codes that indicate the type of protection, the gas group, and the temperature class for which it is certified. It's critical to ensure that the intrinsically safe equipment is properly installed and maintained in accordance with the manufacturer's instructions. Any modifications or alterations to the equipment can compromise its intrinsic safety and void the certification. Purged enclosure detailed. Purging is a method of protection that involves replacing the hazardous atmosphere inside an enclosure with a safe, non-hazardous atmosphere. The purging process typically involves introducing a continuous flow of clean, dry air or inert gas into the enclosure to dilute and remove any flammable gases or vapors. There are several types of purging techniques, each with its own specific requirements and limitations. Type X purging reduces the classification inside the enclosure from Division 1 to non-hazardous. Type Y purging reduces the classification inside the enclosure from Division 1 to Division 2. Type C purging, as mentioned earlier, reduces the classification inside the enclosure from Division 2 to non-hazardous. The selection of the appropriate purging technique depends on the specific hazard present and the desired level of protection. This certification of purged enclosures involves testing to verify the effectiveness of the purging system in maintaining a safe internal atmosphere. These tests include measuring the concentration of flammable gases or vapors inside the enclosure during various operating conditions. Purged enclosures must be equipped with appropriate monitoring and control systems to ensure that the purging process is functioning correctly. These systems typically include pressure sensors, flow meters, and alarms to indicate any deviations from the required purging parameters. Regular maintenance and inspection of the purging system are essential to ensure its continued effectiveness. Gasketed door detailed. The gasket on the enclosure door plays a crucial role in preventing the ingress of flammable gases or vapors into the enclosure. The gasket material must be carefully selected to ensure that it is compatible with the chemical environment in which the enclosure is installed. The gasket must also be capable of maintaining its sealing properties over a wide range of temperatures and pressures. Common gasket materials include neoprene, silicone, and Viton. The selection of the appropriate gasket material depends on the specific application and the properties of the hazardous substances present. The gasket must be properly installed and compressed to ensure a tight seal between the enclosure door and the enclosure body. The gasket should be regularly inspected for any signs of damage or deterioration. Any cracks, tears, or other imperfections in the gasket can compromise its sealing effectiveness. The gasket should be replaced if it is found to be damaged or worn. The design of the enclosure door and the gasket groove should be such that the gasket is properly supported and compressed when the door is closed. The use of a compression limiter may be necessary to prevent overcompression of the gasket. Warning sign detailed. The warning sign on the enclosure serves as a critical reminder to personnel of the potential hazards associated with opening the enclosure when flammable gases are present. The sign should be prominently displayed on the enclosure and should be easily visible and legible. The lettering should be of sufficient size and contrast to ensure that the warning is clearly understood. The sign should be made of a durable material that can withstand the environmental conditions in which it is installed. Common sign materials include aluminum, stainless steel, and plastic. The sign should be securely attached to the enclosure using screws, rivets, or adhesive. The sign should be regularly inspected to ensure that it remains in good condition and is not obscured by dirt or debris. The wording of the warning sign should be clear and concise, conveying the essential information about the hazard and the necessary precautions. The sign should comply with applicable safety standards and regulations. Alarm horn and beacon detailed. The alarm horn and beacon provide an audible and visual indication of a gas detection event, alerting personnel to the presence of a hazardous condition. The alarm horn must produce a sound level that is sufficient to be heard above the ambient noise level in the area. The sound level should be measured at a distance of at least 10 feet from the alarm horn. The beacon must be visible from all directions and must be of sufficient intensity to be seen in bright sunlight. The intensity of the beacon should be measured in candelas. The placement of the alarm horn and beacon should be carefully considered to ensure that they are effectively communicate the alarm condition to all personnel in the area. The alarm horn and beacon should be located in a position where they are not obstructed by equipment or structures. The alarm horn and beacon should be powered by a reliable power source, such as a battery backup system. The alarm horn and beacon should be regularly tested to ensure that they are functioning properly. The testing should include verifying the sound level of the alarm horn and the intensity of the beacon. The alarm horn and beacon should be maintained in accordance with the manufacturer's instructions. Additional considerations. In addition to the specific requirements outlined above, there are several other factors that should be considered when designing and installing electrical equipment in Class 1, Group D, Division 2 hazardous areas. These factors include grounding and bonding, wiring methods, and overcurrent protection. Grounding and bonding are essential for preventing the accumulation of static electricity, which can be a source of ignition in hazardous locations. All electrical equipment should be properly grounded and bonded in accordance with applicable codes and standards, such as the National Electrical Code, NEC. Wiring methods for hazardous locations must be designed to prevent the propagation of explosions from inside the conduit or enclosure to the surrounding atmosphere. Approved wiring methods include the use of explosion-proof conduit, cable seals, and intrinsically safe wiring. Overcurrent protection devices, such as fuses and circuit breakers, must be selected and installed to protect electrical equipment from damage due to overcurrent conditions. The overcurrent protection devices must be properly sized and coordinated to ensure that they will trip quickly and reliably in the event of a fault. The installation and maintenance of electrical equipment in hazardous locations should be performed only by qualified personnel who have been trained in the specific requirements for these areas. Regular inspections and maintenance are essential for ensuring the continued safety of electrical equipment in hazardous locations. Any deficiencies or problems that are identified during inspection should be promptly corrected. Detailed documentation of the installation, maintenance, and inspection of electrical equipment in hazardous locations should be maintained. This documentation should include records of all inspections, tests, and repairs. Let us now consider some practical examples to illustrate the application of these principles. Imagine a scenario where a chemical plant utilizes a genset to provide backup power to critical processes. The genset is located in an area classified as Class 1, Group D, Division 2 due to the presence of flammable solvents. To safely install the genset controller in this area, the following steps would be taken. Firstly, the genset controller is selected based on its certification for intrinsic safety in Class 1, Group D environments. The controller's design inherently limits the electrical and thermal energy to levels below the ignition threshold for the solvents present. Secondly, a Type C purged enclosure is chosen to house the genset controller. The enclosure is certified for Class 1, Group D, Division 2 and is designed to maintain a positive pressure of clean, dry air to prevent the ingress of flammable vapors. Thirdly, the enclosure door is fitted with a gasket made of a material compatible with the solvents present, ensuring a tight seal to prevent vapor intrusion. Fourthly, a warning sign is prominently displayed on the enclosure stating "Do not open panel if gas is present," alerting personnel to the potential hazard. Fifthly, an alarm horn and beacon are installed outside the hazardous area, providing audible and visual warnings in case of gas detection. The alarm system is tested regularly to ensure its functionality. Another example involves a refinery where a gas detector is installed to monitor for leaks of flammable hydrocarbons. The gas detector is located in a Class 1 Group D Division 2 area. To ensure safe operation, the following measures are implemented. Firstly, the gas detector is certified as intrinsically safe, ensuring that it will not cause ignition even in the presence of flammable hydrocarbons. Secondly, the detector is housed in an explosion-proof enclosure, which is designed to contain any explosion that may occur inside the enclosure, preventing it from propagating to the surrounding atmosphere. Thirdly, the wiring for the gas detector is run in explosion-proof conduit, which is designed to withstand the pressures generated by an internal explosion. Fourthly, the gas detector is connected to an alarm system that provides audible and visual warnings in case of a gas leak. The alarm system is tested regularly to ensure its functionality. In both of these examples, the key principles of intrinsic safety, purging, gasketing, warning signs, and alarm systems are applied to ensure the safe operation of electrical equipment in hazardous locations. By adhering to these principles and following applicable codes and standards, it is possible to minimize the risk of ignition and protect personnel and property from the hazards associated with flammable gases and vapors. Let us now discuss the relevant codes and standards that govern the design and installation of electrical equipment in hazardous locations. The National Electrical Code (NEC) is the primary standard for electrical safety in the United States. Article 500 of the NEC addresses the requirements for electrical equipment and wiring in hazardous locations. The NEC defines hazardous locations based on the type and concentration of flammable substances present. Class 1 locations are those in which flammable gases or vapors or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 2 locations are those in which combustible dust is or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Class 3 locations are those in which easily ignitable fibers or flyings are present but not likely to be suspended in the air in quantities sufficient to produce ignitable mixtures. Within each class, locations are further divided into divisions based on the likelihood of the hazardous substance being present. Division 1 locations are those in which the hazardous substance is present under normal operating conditions. Division 2 locations are those in which the hazardous substance is present only under abnormal operating conditions, such as a leak or spill. The NEC also defines groups of hazardous substances based on their ignition characteristics. Group A includes acetylene. Group B includes hydrogen. Group C includes ethylene. Group D includes propane. The NEC specifies the types of electrical equipment that are permitted in each class, division, and group of hazardous locations. The equipment must be specifically designed and certified for use in a particular hazardous location. The NEC also provides detailed requirements for wiring methods, grounding and bonding, and overcurrent protection in hazardous locations. In addition to the NEC, there are other relevant standards that may apply to the design and installation of electrical equipment in hazardous locations. These standards include those issued by the International Electrotechnical Commission (IC) and other national standards organizations. The IEC standards are widely used in Europe and other parts of the world. These standards provide detailed requirements for the design, testing, and certification of electrical equipment for use in hazardous locations. It is important to note that the requirements for electrical equipment in hazardous locations can be complex and may vary depending on the specific application and the local regulations. It is essential to consult with qualified professionals and to follow applicable codes and standards to ensure that electrical equipment is installed and operated safely in hazardous locations. Let's also consider the maintenance and inspection requirements for such installations. Regular maintenance and inspection are crucial for ensuring the continued safety of electrical equipment in hazardous locations. The frequency and scope of maintenance and inspection should be based on the manufacturer's recommendations, applicable codes and standards, and the specific operating conditions. Maintenance activities should include cleaning, lubrication, and replacement of worn or damaged parts. Inspection should include visual examination of equipment for signs of damage, corrosion, or deterioration. Inspection should also include testing of electrical circuits and components to verify their proper operation. Any deficiencies or problems that are identified during inspection should be promptly corrected. Detailed records should be maintained of all maintenance and inspection activities. These records should include the date of the activity, the name of the person performing the activity, and the description of any findings or corrective actions. Personnel who perform maintenance and inspection of electrical equipment in hazardous locations should be properly trained and qualified. They should have a thorough understanding of the hazards associated with flammable substances and the requirements for safe work practices in hazardous locations. They should also be familiar with the applicable codes and standards for electrical equipment in hazardous locations. In conclusion, designing for a Class 1, Group D, Division 2 area requires a comprehensive approach that considers all aspects of electrical safety. By following the principles of intrinsic safety, purging, gasketing, warning signs, and alarm systems, and by adhering to applicable codes and standards, it is possible to minimize the risk of ignition and protect personnel and property from the hazards associated with flammable gases and vapors. Regular maintenance and inspection are essential for ensuring the continued safety of electrical equipment in hazardous locations. It is important to consult with qualified professionals and to follow applicable codes and standards to ensure that electrical equipment is installed and operated safely in hazardous locations.